Hello everyone, this is Wenbing from Microsoft. Today I will give an update for the model Zoo and tutorial SIG. This is the agenda of the presentation. Firstly, I will give an update about the model Zoo SIG, and Mark from Microsoft will also give a presentation about the ONNX model hub. As I mentioned in the last meetup, that quantization and the mobile model is one focus area in our next milestone. So now we have thanks for some Intel guys contribution. Now we have several quantized model uploaded in the model Zoo, like the ResNet 50 and VGG and ChefNet. And this is particularly very useful for the mobile apps. As you can see the following table, we take the ResNet 50 as an example. You can see without too much loss on the accuracy, the footprint and the latency are both greatly improved. And those models are generated by the neural compressor, and the model can be influenced by only runtime without any extra configuration. Also, we have some new kind of the model, which we call the out-of-box model. This model will fuse all the pre and post processing into the model. So when you do the inference, you don't need extra step on the pre and post processing. This will greatly simplify the model inference, and it is more portable because you don't need to worry about those pre-processing libraries in any platform, and especially useful for the mobile apps. And in this milestone, we have checked in the GPU2. Most of people, if you are familiar with GPU2, you always require some model generation algorithm. Typically is a beam search to get the final end-to-end result. So in this example, we fused the beam search into the GPU2 model, so you can get the result directly without any extra processing the output. Then we talk about a little bit about the roadmap in the next half year. Firstly, we always welcome the model contributions, especially for this model, state-of-art model, and the model for the mobile apps, because it becomes much more and more popular now. Another one is that we have a whole discussion about how do we deal with the next operation in the models. Because when ONNX model Zoo was founded several years ago, at that time the offset version is still very low compared to the latest inference engine. We want to find some good solution for that. Finally, we also want to optimize the model uploading process to minimize user when they want to contribute their models. That's all. Then here's Mark.
Hi, I'm Mark Hamilton. I'm a software engineer at Microsoft, and today I want to share with you some work that my collaborator Jason Wang and I have done on creating the ONNX Model Hub. The goal of this work is to create a single-line API that allows users to quickly get started using pre-trained models in the ONNX ecosystem. We want to make this as simple and easy as possible by reducing boilerplate required for downloading models and loading them from the file system. And in particular, we hope that this work facilitates code sharing so that developers can publish their models to the hub and users can download them the same way that they download anything else in the ecosystem. We hope that this will enable people to build flexible applications on top of collections of ONNX pre-trained models that wouldn't be possible without a unified API to connect them all. And finally, one of the goals of this work is to maintain parity with other ecosystems such as PyTorch and TensorFlow, which already contain Model Hub abstractions. There's a few different things we considered when building the ONNX Model Hub. First and foremost, we wanted our versioning scheme to align with the existing versioning scheme that the ONNX/models repository has in Git LFS. We wanted to support multilingual clients because ONNX is not just an ecosystem in Python, but in a variety of different languages. This drove us to investigate a language agnostic protocol layer called the Manifest. It should support user and private hosted hubs so that anyone can deploy their own model hub and use it within their closed infrastructure, but still be able to leverage the common APIs. It should be secure and efficient. It should stop man-in-the-middle attacks with checksums, and it should support local caching so that subsequent calls to the APIs don't require re-downloading the model. And finally, we wanted to make this easy for the ONNX team to maintain, so we wanted to generate this manifest from the existing ONNX/models repository so that this could be done automatically and that this collection of models can be curated without any human input. So to quickly sketch out the main steps of the ONNX Model Hub, it all starts with the ONNX Hub Python client that is built at the ONNX/ONNX repository. Users install that on their machines and then can type onnx.hub.load and pass in the name of a model along with additional parameters. By default, this will point to the main ONNX/models repository where all these different pre-trained models are currently hosted. And in particular, it will point to a manifest file that's stored in that ONNX/model repository. This manifest file then has relative links to all of the different models, which then bottom out in particular files in Git LFS. So when one is queued for downloading, that particular file in Git LFS is downloaded to the model cache, which is a location on the machine that's configurable, and then loaded into the local process, which completes the loop and returns a final protobuf object that one can use for prediction. Now that we've seen the main architecture, we can give a quick tour of the API. You can import the hub from the main ONNX package and use that to load any of the models by name. If you wanted a particular version, you can pass in the offset keyword. And if you wanted to go even further and pin the entire thing to a particular fixed hash of the ONNX model repositories for, say, reproducibility, that's possible as well. And you can also download from user repositories, enabling private or custom style deployments. In addition to downloading models, we also contain some utility functions for, say, setting the cache directory, for inspecting the information of these models prior to downloading, and even querying the models by semantic tags like vision or detection. And finally, you can take a look at, say, the model size or other metadata for a particular model prior to downloading so that you can understand the model before you deploy it to production. A lot of the functionality of the hub relies on a manifest which contains metadata and locations of trained models. And in particular, this manifest is not hard to create. We were able to automatically generate it using the existing markdown tables on ONNX/models. And this allows us to suck in over 120 different models into our initial version of the hub with metadata for checksumming and inspecting the input-output structure of these models and a variety of other features. In this work, one of our big next steps is to create a JVM-based client for the ONNX Model Hub. We currently have implemented a Python client, but the JVM-based client will allow us to make a really nice interface for our new Apache Spark-based distributed ONNX inference code, which allows you to evaluate deep learning models within Apache Spark clusters very easily and simply. And second, we would love to incorporate some responsible AI information into the ontology and the metrics. That way people can kind of query for fairness on models and understand a bit about how their model performs in practice before deploying it into their application. And finally, if you're interested in trying out this work, it's a simple pip install of ONNX Weekly to get the latest bits which have the ONNX Hub. And you can check out that link for pointers to more documentation and more information. And please feel free to drop us a line if you have any feedback about the project or want to kind of continue moving it forward. And thanks, as always, to the ONNX steering committee and everyone who helped along the way to provide us feedback, help us navigate the build system, and help us get this contribution into the main ONNX repository. So thank you all.